Good morning, everyone. My name is Ruoying. I am an oceanography professor at North Carolina State University. Our project funded by NOAA-IU's Coastal Ocean Modeling Testbed, the COMT program, is titled Developing an Integrated Coastal Water Predictive Capability to Promote Resilience to Water Risks. Other team members of this project, including Deborah Hernandez and Jennifer Dorton from Sakura, Haibo Zhong, Joseph Sembang, and Jennifer Warlow from NCSU FASM Science Team, and Charlton Gavarino from Second Creek. So the 3 years COMT project started in April 2019, so we are in year 2 now. Deborah serves as the transition PI, and I serves as the scientific PI. So we have NOAA Co-ops, CSDL, and the National Water Center as the federal partners of this project, and a group of people from Sea Grant, Navigation, Water Management, and Ecosystem Services as regional partners. So the goal of this project is to develop an integrated coastal water predictive system that can deliver new water intelligence to support decision makings both during high impact weather events such as hurricanes, storm surge, and also for the routine water management, including ecosystem health, transportation, and agriculture. And the scientific needs of this project is because as the coastal ocean prediction science is pushed to the land-sea boundary, we need to have a robust, efficient, and multi-scale coupling methodology to describe the interactions between terrestrial hydrology and the coastal ocean at high resolution and fidelity. And we'll be addressing this need by developing a prototype baroclinic prediction system that couples the ocean with the ocean predictions made available by NOAA's national water models, and ultimately transition such a system to NOAA's operational agencies. So the system is developed for the entire US East Coast, but we have 2 specific river-ocean subsystems in our project as a focus. So the 2 subsystems represent distinct end members. So one is for the Pamlico Sound, North Carolina, which is a classic lagoonal system where river-ocean exchange is only through 3 small inlets. And the second subsystem is for St. Johns River, Florida, where the river-ocean interactions are acting continually and affecting a suite of human societal functions. The stakeholder of the project and the project products, including communities in the flooding and the coastal inundations, and the agency and the communities in the water resource and water supply management, as well as agencies and peoples working on water quality risks to marine ecosystem and coastal communities, and also including communities in the marine transportations and navigations. So we're continuing building our outreach of this project and expect this stakeholder and user list to continue to grow. So research approach, the idea is to develop a prototype river-ocean coupled prediction system by linking National Water Center's stream flow predictions with the 3-dimensional baroclinic ocean predictions. So we can make a nowcast and forecast of total water levels, compound flooding, and the currents, water temperature, salinity, and the residence time for the 2 study sites. And this effort is conducted in close collaboration with NOAA's operational agencies for research to operation transition, as well as with end members for their engagement to develop the useful product development. Now, the national water models run by National Water Center is this WRF hydro-based prediction system, which provides operational river stream flow, nowcast, and forecast at different timescale. The 3-dimensional ocean circulation model is based on an existing system that our team at NC State has developed with the support from NOAA IU's program. So we call this system Synapse, and the system has been running routinely for a couple of years, providing daily nowcast and forecast of ocean conditions for this larger domain. And end users of such a system have access to the ocean predictions either from NC State website or from NOAA IU's EDS web portal. And in this COMP project, we are developing two-way multi-level nested system to downscale the ocean predictions to specific study sites. And this involves using the existing Northwest Atlantic ocean models as level 1 domain and two different shelf scale level 2 domains, and also the river sound scale level 3 domains to provide the high resolution river ocean couple predictions for Pamlico Sound and the St. Johns River regions. So showing here are some preliminary results, and in this case we are looking at the St. Johns River system, and this is level 3 model simulated sea surface height along with surface velocity by showing by the vectors, and sea surface temperature in the middle column and sea surface salinity for the right column. So there's a coupling between river and the ocean models. So we are looking at 160 meter resolutions predictions produced by this river ocean couple system for St. John's. Showing here, this is similar animations, but for Pamlico Sound, we are looking at the transition from the L1 domain to L2 and all the way to L3. And we are looking at the model simulated sea surface temperature, sea surface salinity, and surface velocities. So at L3, we'll also start looking to the detailed river ocean coupling and also adjacent shelf circulation response at the 160 meter resolution. So in summary, our goal is to build an integrated ocean river coupled prediction system that can deliver new water intelligence to support vital decision makings. And the idea is to couple the baroclinic ocean prediction with the World Hydro-based NOAA national water models, and ultimately transition such a coupled prediction capability to NOAA's operational agencies. And we have developed a functional multi-level nested models for 2 sub-region study sites, working on extensive validations against observations from regional networks, and also working on detailed ocean river couplings. We are engaging a suite of stakeholders, ranging from the flooding and coastal inundation community, water resources, and the water supply management communities, also the communities working on water quality risks and marine transportation and navigation. Thank you so much for your attention.